Welcome to today's mathematics lesson. And in our lesson for today, we are going to talk about sets, and specifically we are going to talk about subsets. This is just a continuation on the things that we did in the previous lesson. In the previous lesson, we are talking about how to determine the number of subsets and proper subsets when you're given a set. But in this lesson, we'll be talking about how now to determine the number of elements that are in a set when you're given the number of subsets. So now, in our previous lesson, we have discussed, we said to determine the number of subsets in a given set, you say 2 to the power of n, where we know to say n is the number of elements that are there in a set. To determine or rather obtain the number of proper subsets, you say 2 to the power n minus 2. This simply means when you find the number of subsets, then you subtract 2, you're going to obtain or rather get the number of proper subsets in that set. But now our focus for today, we want to focus on this. When you're given the number of subsets and then they need you to find the number of elements, which is basically what? N. So in this case, it is simple and straightforward, where we know to say we'll be using the same formula, but with a blend of the knowledge that we have for indices. So here, our first example that we are having, we are taught to say the set W has 64 subsets. Find the number of elements in set W. So here we know to say to obtain the number of subsets, we use the formula that one, which is basically 2 to the power of n. But this will be equivalent to what? We are taught to say the number of subsets are what? 64. So we are going to write 64 there. So using index notation, we know to say if you're having an expression like this, you are looking for the unknown power. So if you're looking for the unknown power, you have to make the bases the same. So again, using the same index notation, we need to rewrite this number, which is 64, so that it can have a base which is 2. So to do that, we are going to say 2 to the power of n, which should be equivalent to rewrite this 64 so that it can have a base which is 2. This is the same as writing 2 to the power of 6. Because this simply means you are multiplying 2 by itself 6 times. So since here the bases are the same, we can drop the bases, meaning we are remaining with n, which is equivalent to 6. And then this simply means set W has 6 elements. To pick another example, we have our example here, which is example number 2, which is telling us the set A has 16 subsets. Find the number of elements in set A. So in order for us to find the number of elements in this set, we are going to use the same procedure. We know to say our formula will still remain the same, where we are going to say this is 2 to the power of n, which would be equivalent to. But in this case, we are going to say the number of subsets there is what? 16. So this will be equivalent to what? 16. So since this should be equivalent to 16, we are still going to apply index notation, where we are going to say how can we rewrite this 16 so that it can have a base which is what? 2. In that case, we are going to say this is 2 to the power n, which should be equivalent to 2 to the power of 4. When you multiply 2 by itself 4 times, you are going to get 16. So since the bases are the same, we are going to drop the bases. Therefore, we are remaining with n, which would be equivalent to 4. From there, we can conclude by saying this set A has 4 elements. And basically, this is how you obtain the number of elements when you are given the number of subsets. Please make sure to follow, like, comment, and subscribe in order for videos like this to be reaching you wherever you are. Thank you, and see you next time.